In this video, I'm going to explain what wave motion is and the types of wave motion and how we can calculate problems or solve problems involving wave motion. So therefore, a wave is a disturbance in a medium that transmits energy. A disturbance in a medium that transmits energy. We call it a wave or waves. And we have two types of waves, which are transverse and longitudinal. We have two types of waves, which are transverse and longitudinal. And then a transverse wave is a type of wave in which the vibration or the movement of particles in a medium are perpendicular to the direction of travel of the wave. So transverse wave is a type of wave in which the vibration of particles in a medium are perpendicular to the direction of travel of the wave. And examples of transverse waves, we have water waves, light waves, and waves in a rope. These waves, when a wave is traveling horizontally, the particles, the vibration or the movement of particles in that medium in which this wave is traveling, they move or they vibrate perpendicularly to the travel of that wave. Those, we call them transverse waves. And longitudinal waves. A longitudinal wave is a wave in which the movement of particles are parallel to the direction of travel of the wave. So longitudinal wave is a wave in which the movement of the particles are parallel to the direction of travel of the wave. And examples of longitudinal waves, we have waves in a spring. Waves on the spring are longitudinal waves, and the sound waves are longitudinal waves. Now here, the particles move parallel to the direction of the wave. For example, if we have a wave traveling in that direction, the particles in that medium, it can be a liquid or gas. The particles there, they move parallel. They move parallel to the direction of that wave. So these waves, we call them longitudinal waves. In a transverse wave, we said they move perpendicularly. If we have, that is a wave, then the particles here move perpendicular at right angle to the direction of the wave. Here we are explaining on transverse wave. Okay, so let's move on to graphs of transverse waves. So under transverse waves, we have graphs which represents how the motion of a wave. And then under the same graphs, we have what we call wavelength, amplitude, period, and period. Okay, so wavelength, as you can see, this is the distance from here to there, where this distance forms a wave circle, so that we call it a wavelength. So it can be from this point to that point there. That can also represent a wavelength to make a complete circle. Now period is simply the time taken to form one complete wave. That's the period. Then we have what we call frequency, amplitude, the highest from the resting position to where that wave, the highest mark or the highest point at which that wave can go high. That is the amplitude. So if you have been asked to find the amplitude, just simply see or calculate the distance from the resting position there, and see where the highest point of that wave. Okay, so the wave motion, we have an equation. This is the equation that we are going to be using, or that you can use to calculate the velocity, wavelength, and frequency. So this symbol here, that is the wavelength, and that is frequency, and this is velocity. So you can use this formula to calculate the velocity of a wave. Then from there, I have this question for you guys. So you need to study this diagram below and answer the questions that follow. We have already learned these. So I just want you guys go through, study this diagram, and then from there, answer the questions that follow. So the questions are, what is the amplitude of the wave? What is the amplitude in this wave, which is here? And what is the wavelength of the wave? And then given that the speed of the wave is 4 meters per second, calculate the frequency. So this is what you need to try, and then send the answers in my inbox. And then from there, we're going to solve this together. Thank you very much for watching.